In this video, we will go through 3 examples of calculating epidemiological measures. We will look at prevalence, incidence, relative risk, and odds ratio. Epidemiological measures are easy to calculate. You have a number of options available: by hand, Excel, statistical software, or online calculators. If you calculate by hand or Excel, you run the risk of making errors with your formulas or arithmetic. So a better choice is to use software. In some institutions, statistical software is not available or may be cost prohibitive. Online calculators can be accessed from the internet when statistical software is not available. When choosing an online calculator, be sure that it is from a reputable source, a college or university, or a professional organization. In this video, we will demonstrate the use of one online calculator from Vassar College. It is called VassarStats. In a 2-year study of chronic obstructive pulmonary disease, COPD, there is a fixed population of 1,500 people participating. At the beginning of the study, 11 people are identified as already having COPD. During the first year, 6 additional people are diagnosed with COPD. In the second year, 5 additional people are diagnosed. Here are 3 questions to address. What's the point prevalence of COPD at the beginning of the study? What is the period prevalence of COPD for the 2-year study period? What is the incidence rate of COPD in the first year of the study? Here are the answers to our 3 questions. What's the point prevalence of COPD at the beginning of the study? For point prevalence, we want to know the percentage of people with COPD at a given point in time. The numerator is 11 because there are 11 people diagnosed with COPD at the beginning of the study. The denominator is 1,500 since that is the total study population size. Therefore, the point prevalence is 11 divided by 1,500 or 0.73%. What is the period prevalence of COPD for the 2-year study period? For period prevalence, we want to know the percentage of people with COPD over a specified period of time. The numerator is then the number of people that had existing COPD at the beginning of the study and the number diagnosed over the 2-year study period. The numerator is then the sum of the 11 people with COPD at the beginning of the study, the 6 diagnosed in the first year, and the 5 diagnosed in the second year. The denominator is 1,500 since that is the total study population size. Therefore, the period prevalence is 22 divided by 1,500 or 1.47%. What is the incidence rate of COPD for the first year of the study? Incidence is the number of new cases diagnosed in a given time period. In the first year of the study, 6 people were diagnosed, so the numerator is 6. The denominator is the number of people at risk for developing COPD in the first year. So this is 1,500 minus the 11 people who had COPD at the beginning of the study, or 1,489. The incidence in the first year is then 6 divided by 1,489, or 0.4%. As an exercise, compute the incidence rate for the second year of the study.
In our next example, we will look at the association between stroke and cholesterol levels. You have 1,500 subjects with low cholesterol level and 1,200 with high. After 20 years, 30 of the low cholesterol subjects suffer strokes and 60 suffer strokes in the high cholesterol group. What is the relative risk of stroke for high compared to low levels of cholesterol? We will use the VassarStats calculator in this example to calculate the relative risk. Here we begin on the VassarStats homepage. We scroll down in Sitemap and click on Clinical Research Calculators. We then will use Calculator 3 to compute the relative risk. Scroll down to input your data. Here, Group 1 is those with high cholesterol. There is 60 who suffered strokes in the high group and 1,140 who did not. For the low cholesterol group, there was 30 who suffered strokes and 1,470 who did not. Then click Calculate. Scroll down, and here the risk ratio is the relative risk of 2.5. The relative risk is 2.5. The risk of stroke is 2.5 times greater among those with high cholesterol compared to those with low cholesterol. For our third example, we will look at the risks associated with pancreatic cancer. In a case-controlled study, 175 men had pancreatic cancer and 580 did not. Each man was interviewed to obtain information on their fat intake, classified as low and high. 135 of those with pancreatic cancer had high fat intake, while 40 had low. For the non-cancer group, 355 had high fat intake, while 225 has low fat intake. What is the measure of association between high fat intake and pancreatic cancer? Because this is a case-control study, relative risk cannot be directly calculated. Instead, an odds ratio is calculated as an estimate of the relative risk. We'll use the Vassar Stats calculator to find the odds ratio. Here we begin on the Vassar Stats homepage. We will scroll down in Sitemap to Clinical Research Calculators. We will click on Calculator 3 for computing the odds ratio. We scroll down to enter the data in the 2x2 table. We will let Group 1 be those with high fat intake. There are 135 that had pancreatic cancer with high fat intake and 40 who had pancreatic cancer with low. In the non-pancreatic group, there was 355 with high fat intake and 225 with low. We will then hit Calculate. Scroll down and you will see that the odds ratio is 2.14. The odds ratio is 2.14. This means that the odds of having high fat intake among those with pancreatic cancer are 2.14 times greater than the odds of having high fat intake among those without pancreatic cancer. Here are the key points for this video. When computing prevalence and incidence, it is important to adjust your numerator and denominator for the time period of interest. The correct risk measure will depend on the type of study. When using an online calculator, be careful to note the orientation of the 2x2 table. Different calculators may be set up differently. When choosing and computing measures, read the research question and study design information carefully, as there are subtle differences in the epidemiological measures.